Our next lesson is on exponents and order of operations. To simplify a numerical expression, you place it in its simplest name. So for example, the simplest name for 2 times 8 plus 2 times 3 is 22. An exponent tells you how many times a number, which is the base, is used as a factor. And a power has two parts, a base and an exponent. So down below we have the example of 2 to the 4th. The whole term, 2 to the 4th, is considered a power. The small number, the exponent of 4, is on the 2, and the 2 is the base. So 2 to the 4th means that we have 4 2's, or 2 times 2 times 2. So we use the order of operations when simplifying numerical expressions. The order of operations tells us what order to perform the operations in. You may be familiar with the phrase, "Please excuse my dear Aunt Sally." So each letter stands for a different operation and the order that we need to perform it in. First, we would start with the parentheses or grouping symbols, followed by exponents. Then multiply from left to right, or divide from left to right, whichever comes first. And lastly, we will add from left to right or subtract from left to right, whichever comes first. You evaluate an algebraic expression by substituting a given number for each variable, and then you would follow the order of operations. Okay, let's look at some examples where we use the order of operations to simplify. Number 1 says 3 times 6 minus 4 squared divided by 2. There are no parentheses, so then we move to the next step, which is exponents. And there is one exponent. So we're going to rewrite the 3 times 6. 4 to the second is 16, 4 times 4. And then we have divided by 2. Now we have multiplication and division in the next step. So we can just go left to right. We have 3 times 6 is 18, minus 16 divided by 2 is 8. And then 18 minus 8 is 10. So our simplified answer is 10. And number 2, 32 plus 6 squared minus 14 times 3. So again, exponents first. 32 plus 36 minus 14 times 3. Okay, we have to do the multiplication next, so let's just bring down that 32 plus 36. Whoops, messed up a little bit there. Okay. All right, 14 times 3 is 42. And now since we have addition and subtraction, we can just go left to right. So 32 plus 36, we get 68. Then minus a 42. And that simplifies to, there we go, 26. All right. Number 3, we have some parentheses. So we want to simplify in the parentheses first. In our first set, we have 5 plus 3, which is 8. And then once you have only one number in parentheses, you do not need those parentheses anymore. Let's bring down that divided by 2 plus, now here we're going to keep our parentheses for another step. Let's do that 5 squared, which is 25, minus 3. And in our next step, let's go ahead and simplify in those parentheses. 25 minus 3, or 22. Okay, now division. So 8 divided by 2, 4, plus 22, and we get 26. All right, and our last one here are for these. Again, simplify in parentheses first. Let's bring down that 8 divided by 9 minus 7, or 2, plus 13 divided by 2, or 6.5. Okay, 8 divided by 2 comes next, which is 4, plus 6.5. Add those up, and we get 10.5. Nice. Okay, in our next set of examples, we're going to look at evaluating each expression, which means that we substitute in values for our variables, and then we follow the order of operations, just like in our last examples. So for here, it says evaluate each expression for c equals 2 and d equals 5. So anywhere we see a c, we're going to substitute in 2, and anywhere there's a d, we'll substitute in 5. So in our first one here, for 4c, we're going to put 4 times 2, then minus 2 times 5 divided by 2. Okay, let's go ahead and simplify some multiplication. 4 times 2 is 8, minus 2 times 5 is 10, and then a divided by 2. Okay, we have to do the division before the subtraction. So go ahead and bring down the 8 minus 10 divided by 2 is 5. And 8 minus 5 gives us 3. Okay, in the next one, let's substitute in first. So for D, we'll have a 5. And then plus 6 times 2 divided by 4. All right, go ahead and do the multiplication. So 6 times 2 is 12. Divided by 4. Again, division before addition. So 12 divided by 4 is 3. 5 plus 3 gives us 8. All right, in the next two, we have some exponents. So let's see. C to the fourth, or 2 to the fourth, minus 5. Now 2 to the fourth means we have 4 2's. So 2 times 2 times 2 times 2. Or 16, and then a minus 5. 16 minus 5 gives us 11. Okay, last one on this page. 40 minus 5 squared plus 2 times 5 times 3. So you can use the X for your times symbol, or you could use a little dot. All right, let's simplify exponents. So 40 minus 25. Now here we can multiply straight across in one step. 2 times 5 is 10. 10 times 3 is 30. Okay, now we're going to do addition and subtraction in one step. Since there's both, we're just going to go left to right. So 40 minus 25 gives us 15 plus 30. Final answer, 45. Okay, our last three examples, same idea, except they're a little trickier, might get some larger numbers. So let's see, in number 9 we have r times t squared. So let's substitute in this case, 9 for r, and then 14 for t. Okay, order of operations says to do exponents before multiplication. So we have 9 times, now 14 squared is 14 times 14, or 196. And then if we take 9 times 196, we get 1,764. Number 10, r squared times t, or 9 squared times 14. 9 squared is 81 times 14 gives us 1,134. And last but not least, number 11. All right, substitute in first. So r is 9, t is 14, and we're going to square that. All right, order of operations tells us to simplify inside parentheses. So 9 times 14 is 126. And if we square that, we're going to get 15,876. Okay, and that concludes our lesson on exponents and order of operations.